It's my pleasure to introduce to you this course. In this module, Module 0, or Foundations, we're more or less going to just talk about like the nature of the course at a very high level, how it's going to be delivered, how it's going to be assessed, and we'll cover those aspects separate from the actual course content. As always, if there's questions, you are free to reach out to me. So, we'll talk about how this course works. So first of all, it works largely because of you. I assume that because of your prerequisites and because of the nature of this third year class, that you already have a good amount of Python or Jupyter experience, that you have at least second year level calculus ability, linear algebra, and probability. You have some programming and data experience. This goes beyond just having Python and Jupyter sort of rudimentary experience, but you know how to formulate problems and work with data sets. I'm also assuming that you understand that this class is a machine learning class, and as such, we're going to base our work on probability, on building models, and on optimizing those models for downstream tasks. It's understood that deep learning is a special case of these ideas, the ideas that are going to come up in machine learning. It has powerful representations, and as we'll see, it'll also be part of this course. If any of these feel shaky, that's okay, right? It's crucial that you understand that this is not a gate. This module and Module 1 will help you see the general landscape of the class. And I want to assure you that we'll review the mathematics throughout the term. I can provide additional resources, including math background, including getting your Python and programming skills up to par. So if at any point you're concerned that you need some additional boost in any of these areas, I'm more than happy to do the work and provide you with extra help. So how does this course work? This year is the first year that I'll be trying something called a flipped classroom. And I've heard a lot of high praise for this method of delivery. The idea is that instead of coming to class, listening to me talk for an hour and a half, and then going off and doing the actual work on your own, the idea is that we will learn the foundations before you come to class. You'll watch videos. My lectures will be posted in these video forms. And then you'll come to class prepared, and we'll use our time together for interactivity, for practicing, and for more direct coaching. So before class, we'll be having these short videos and reading potentially assignments, and usually a quick check, so a small little quiz you can do on your own just to make sure that there's no misconceptions. And then in class, all together, we're going to do problem solving, discussions, feedback, and then applying the ideas we see in these videos to real data that are held out for the in-class component. This will work well, I think, because we'll have more active time together. Instead of just sitting there listening and asking the occasional question, we will really have a conversation about these topics. This will help you get faster feedback. So, through these conversations, we can go back and forth to surface any kind of challenges or any misconceptions. And I think this will help also focus on the hard parts and things that are more unique to you. Rather than me, these lectures are largely going to be for everyone, but when we're interacting in person, you want sort of fine-tuned help for you personally. It's not going to be the case that this is going to give you more work. So even though you have these videos being posted and occasional reading, your involvement in this class, the amount of hours you put into it, should be about the same as it would be if we were doing kind of the standard approach. It's going to be a lot more work for me. I've been doing a lot of back-end engineering for this class, but I don't mind. It's fun. So in these videos that are posted, I'll largely try to include these kind of pencil prompts. When you see the pencil emoji, I'll usually suggest you think about a bit of a prompt. You pause the video, and you should write down any ideas or potential answers to these prompts that I'm going to give you. You should also write these along with any questions you have. So even when there's no prompt and there's something in the material that is confusing to you or that you want me to go into more depth on, you will jot it down somewhere and then bring all of this to class. Where do you jot it down? Jotting it down on paper works really well, right? So there's a lot of evidence that just writing down your ideas and your thoughts on paper provides a lot of cognitive benefit. A lot of people use tools like Obsidian or Notion, which are both very similar programs that basically kind of organize links, like markdown notes linked together. I want to just flag OrgRoam. So OrgRoam is essentially a note-based program that lives inside of Emacs. And I love Emacs, so I like OrgRoam, but just throwing it out there. It's going to be important for you to write these responses in your own words, right? So writing, like answering these prompts, writing down your questions, this is you for your own benefit, right? You're not going to be marked on these prompts. We're not going to be evaluating anybody on them. Any questions you have, you bring them in. These are your questions. So it's important that you're not relying on others or tools to do this work for you, right? So I think that's important to mention. When we're in class, we're going to begin little sections by doing a quick check of your understanding. So both in the videos, there'll be a little check-in where you can answer some questions for yourself. When we get to class, there will be an additional check, and that check will actually be marked. And then there's going to be some hands-on. I'll explain what that means in a moment. So your role is just to come to class prepared, right? So watch the videos, click on all these links, have questions ready, and then work with your peers and keep on understanding what your assumptions are and what you're bringing into class and what you want to get out of class, right? So be aware of your own goals. If you prepare, then the work will be meaningful. If you're not prepared, then you're unprepared at your own cost. So the way that this is going to work is that I'm mostly going to have delivery in the form of modules. So some forms of the flipped class involves like a full hour-and-a-half lecture, which you have to watch as a whole. I'm going to try to avoid that. So it's really hard to sit through an hour and a half for many people of content. So I'm going to generally try to break down modules into 30-minute videos and then 30-minute in-class sessions. So every lecture will have 3 of these modules accounting for an hour and a half of in-class time, and you will have watched approximately 3 videos of 30 minutes length each, so that the time sort of adds up. So for one module, there's going to generally be roughly a 30-minute video, and then in class, we have a 30-minute activity. That activity is going to follow this flow, the 4 Ds. The 4 Ds are diagnose, do, debrief, and decide. And you can kind of see visualization here. So you watch a video before class, and then in class we walk through these steps, and then all together this forms a module. There should be on the order of about 60 modules this year. Some of them might actually be things like quizzes or in-class exams and that sort of thing, but there'll be about 65 modules. And these modules are grouped by sort of topic or high-level concepts. So, this is actually, may not be relevant to you, but it might be something like math and stats would be a section, and then within that section there'd be a bunch of modules that correspond to that topic. So we'll not just in aggregate, like these modules are going to be pretty quick, but in aggregate these modules will sum up to a deep understanding in a broader topic. So what do I mean by the 4 Ds? So within 30 minutes we'll have these 4 phases. So the first phase will be diagnose. This is where we do a quick check of our understanding of the topic. There'll be a little quiz, kind of a quick little, maybe some questions to answer. This takes about 5 minutes, and then you return it, and then it's part of your overall mark for the class. The do phase is the longer phase. This is normally going to last about 15, maybe even 20 minutes. This is where I provide you with a Jupyter notebook with some activity that practices the understanding of the module, of the video you just watched in this module. So you're going to work on this for about 15 or 20 minutes. We'll discuss things as need be, and then afterwards, as a group, we'll discuss our experience for about 5 minutes. That's the debrief phase. And then in your notebook, for your own benefit, is the decide phase. That's where you take what you've learned, take what you are yet to learn, and decide on what you need to do next in order for you to kind of wrap up this module. If all you need to do next is like come to office hours or ask me a question, then that's what you write down in the decide phase in your preferred notebook. I think all of you have seen this website by now. This is still subject to change because I'm actively working on this too. Actually, I'll just click on the course website here. So I should, as you know, the slides are interactive. So links are all clickable, and then you get led out, and it's on the web, so you get led into other websites. Anyway, this first module up here is the course operations. This is where the syllabus is, links to student declaration of absences, important dates, accessibility and accommodation, and some additional detail. This very video you're watching right now will have been linked somewhere up here in the corner in like an ops video. So it's not content, it's just about the course. It's going to be a video here, and the slides will be up here somewhere too. The more important part is down here at the bottom. So down here is the list of all the modules in the class. A lot of the time, a lot of them will be inaccessible, as you can see here, but then some of them will be accessible. You can click on those, and then you get a link to this window over here. This window will have a material like links to the slides. So click on here, you get the slides. The video will be here, linkable and viewable. There'll be some text, some other links. Everything related to the module will be sort of live inside this area, right? And so I've posted a few of these so far. I'm still working on it. There's going to be, so here at the top you can see these modules are colored different ways. So blue refers to theory, which basically follows the approach I mentioned a moment ago. But occasionally we'll have things like quizzes. So this is where we take the 30 minutes of in-class time for that little module, and then we do a little quiz. So instead of taking 20 minutes or 15 minutes, we take the full 30 minutes to do a quiz. It's a bit more in-depth, and then just the diagnose phase of the 4Ds. And you submit it, and you get marked on it. I'll note also here that you can search these modules if you're looking for something related to like supervised learning. Then you can search, and then you get the appropriate modules here. So I think that's nice. Again, this website's in active development, so down here there'll be a leaderboard. But fortunately, I took a photograph of what that looks like. I'll show that to you in a moment. So hopefully this won't change too much, but hopefully this is self-explanatory. Let's go back to the slides. There we go. So become familiar with this. Hopefully this will be a comfortable place to spend your time. We're also going to be doing work in teams. So each of you would have by now been assigned to a team of 2 or 3 students. If you need to change the teams now or in the future, we can do that. Just come to me and we'll work it out. The idea for this is that you work faster if you can explain things to somebody else, if you can critique your work, shared work, even the work of others, and you can build work with others. This is the Darmok and Jalad approach to teamwork. For those of you who are familiar with Darmok, regardless, this is going to be, I think, helpful for everyone. And it'll also help you constantly be engaged. So when you come to class, you're not just waiting for me to come around, you have someone to talk to and work out problems with. So artifacts you and your team will generate together will count towards your grade to a large extent. You'll be producing notebooks, Jupyter notebooks in class that you'll be submitting. Sometimes I'm going to ask you to just produce a figure or a table, maybe a decision record. So this is going to be a case-by-case basis. It'll be clear when you're meant to submit something for grades, and your team will be submitting things together, right? Other things are done individually. So quizzes, exams, these are done individually. If you miss something, or if you fall behind to some extent, you can go back and regain points from previous weeks or modules. But this is capped, and we're not going to let you game the system by just doing an awful lot of work. Quality is always more important than quantity, at least in the case of marks. I want to point to the Hawthorne effect, so you can read about it at this link. But the Hawthorne effect basically also demonstrates that you're on your best behavior if you're working with someone. Someone's kind of like beside you. This isn't universally the case, nor is it the case in all situations. But the idea here is more or less to have you be on your best behavior by working together with people. In class, sometimes we'll be discussing topics, or there'll be the Jupyter Notebook during the do phase, as I mentioned earlier, and there'll be material that you have to find online. And this can be too much for one person to do quickly on their own, so it might be the case that one of you is filling in the Jupyter Notebook, and the other one is on the web looking for resources, reading papers, and so on. I just recommend that when you're in a team, you swap those roles occasionally. So, do as you wish. I'm not going to be prescriptive about that, but it's going to be good for each member of the team to have experience with the different kind of roles you end up having in team settings. So the missing little frame at the bottom of the website a moment ago was the leaderboard. As your team is getting submitting work and getting graded on it, your team gets points, and the points are tracked over the semester. And this largely will be based on participation. So the more you're involved in the class, the higher your leaderboard ranks will be. We'll just track you over time. The teams will be anonymous, so you don't necessarily know who's on team X. At least you won't from me. And there we have it. So the higher you are in the leaderboard at the end of the semester, the higher your associated grade is going to be, and the lower, associatedly lower. So I will recommend doing the quick check before class. I mentioned that this will largely be not marked, but sometimes I will be asking you to submit things before class. There'll be mini labs you do in class. These are submitted. So basically, again, whenever I ask you to submit something as a team, you do so, and you get points for that. There are guardrails, like I mentioned a moment ago. So you start at 0 and keep on building, but there's going to be kind of limits. So the first thing I suggest you do before we actually start in class is to confirm with your team, talk to them. I don't care if you're using Microsoft Teams or Discord or some other platform as a channel to discuss. I would prefer it if you have a means that you could add me. So if you need me to resolve anything, or if you have questions for me, it's gonna be good if you could add me. So everyone at Dell is on Microsoft Teams, so you might want to consider just having a little team for your team. You ought to have repository access, so make a 3151 repository in GitHub, for example. And I recommend checking in periodically. It doesn't have to be 20 minutes per week, but before every lecture or after every lecture, or at least once a week, check in a little bit to make sure you're both on track with the material. The syllabus is here. As you know, we meet. So this is incorrect. I apologize. So this is for another class. The correct numbers should be in the syllabus. Moving on. As you know, the key dates are 8th of January, 22nd of January, so on. We'll have a final exam in class on the 9th of April. So participation in in-class work, this is basically teamwork. This is the 10% of the mark. There'll be weekly quizzes, approximately weekly quizzes, which will count for 35% of the mark. This is done individually. There'll be practical assignments, so actual take-home assignments in which you do experiments, you build models, you test them. These aren't massive projects, but you write code, you interpret results, and combined this is going to be worth 20%. And then the final in-person closed controlled exam will focus on concepts, math, reasoning, not just memorized APIs, and this is going to be worth 35% of the mark. Generally, the course will start by focusing on core machine learning principles and theory. This can include topics like the bias-variance trade-off, model evaluation, regularization. Then we go into learning paradigms like supervised, unsupervised, and self-supervised learning. We'll talk about feature and data representations, so an introduction to something called representation learning, which we'll just touch on in Module 1. We'll talk about dimensionality reduction. And then finally, as we have the groundwork for machine learning generally, we'll increasingly go into neural networks and more modern deep learning and transformer-based architectures. So my name is Frank Grgic. I have been working in AI for quite a while, ever since I was an undergrad. I am a professor in computer science. I work in AI. I started really focusing in natural language processing, and then this grew to incorporate artificial intelligence in healthcare settings. And then this is also evolving now to safe AI and responsible AI in various means. This is all very important topics to me. The more information on me can be found elsewhere. We're not likely to have TAs this year, so it's just going to be me having to deal with everything, so go lightly. So we can ask questions on the forum, so we'll all be added to a forum, and you should have a link to that already. There'll be office hours and in-class communication for deeper discussion. And if you want to email me, this is fine. If you need to do that for privacy reasons, go ahead. I just ask that you start your emails with this code. The subject should start like square brackets CSCI 3151. I want to say that, getting stuck, you are going to get stuck at some point. At some point, it won't be clear what I'm asking you to do, or it might not be clear like what a concept is from the theory. I'm going to try to avoid the former as much as possible and the latter, but chances are we're going to need help at some point. But it's up to you to get out of that. So there's lots of ways for you to get unstuck. So just keep an eye on it and be proactive. Machine learning matters, not just for courses, but it really matters in machine learning, right? So it's not just about not cheating on an assignment so that you get marked appropriately, although that's part of it. When you, through this class, you're going to further your career in machine learning, and therefore you might work on any number of the very kind of critical or impactful areas in which AI is being applied. AI can be used to decide whether somebody gets a loan or not, whether a applicant gets hired or not, or gets admitted to a university or not. Maybe you'll work in a hospital setting or a healthcare setting where you're using AI to decide who gets treated and who doesn't. All of these clearly are really important factors for individuals and then therefore for society. So, adopting an ethical, high integrity pose or perspective now, as soon as possible, will help going forward. I might be able to tell you stories of instances where I've observed some of my peers sort of taking shortcuts, and it's never a good idea. Values we care about include integrity. So any work you present is honestly your own. Honesty itself is basically reporting what actually happens in experiments. So don't cut corners. Don't be embarrassed by poor results or negative results. The important thing is trying to seek the truth, as cheesy as that sounds, and that's what we're all about. We'll never actually achieve perfect truth, but we can always try to reach for it. Accountability basically means explaining and defending your decisions. If I ask you why you did made a certain decision in an assignment and you have no idea why you did, that's not very accountable, and that's going to be pretty suspicious too. Similarly, if you made a decision that you do understand, but you can't really defend it with a rationale, that's also not ideal. So you want to be able to be accountable for your decisions. Like the buck stops with you, so to speak. That's important as well. We'll all try hard to create an environment where you don't even feel like not only the need to cheat, but even the benefit of cutting corners. I don't expect anyone really to do that, but we need to always mention this at the beginning of a course. Collaboration, of course, is going to be okay, right? So it's okay to discuss high-level concepts and high-level strategies with classmates. What did the professor mean by that? What did this paper mean by this? You can ask for general hints. So what library function might help here? How does pandas work? So things of that nature. You can, of course, go to blogs, read papers, read documentation, watch videos online, even use large language models, with caution, right? As long as you cite it appropriately. If you are going to end up using a reference, make sure you cite that reference. I got this information from this paper, provide the link, properly formatted and all that. You'll be working in teams. So of course, when you're working with a team, you're meant to collaborate very closely with one another. So by all means. One thing you shouldn't do is share a copy, code, or written solutions for graded work. Like the assignments I mentioned earlier, they're going to be graded, so don't share them with, outside of your team. You won't be able to collaborate on quizzes or exams, or at least we're going to try hard to make that as close to impossible as possible. But you won't be able to do that either. Don't fabricate or massage experimental results. If you're getting a result that's almost better than a baseline, but not quite, leave it as such. Don't tweak anything. I think that goes without saying, but still you want to mention it. And also, you shouldn't post course materials or solutions on public sites during the term. Everything I'm posting online is under, all the material is under a Creative Commons license. So like you can post links to the slides and the videos, that's open. But anything you write, like say for a quiz or an assignment, that's not to be shared. If you're in doubt about any of this, just ask me. It takes 30 seconds, maybe it takes 25 seconds, and it'll potentially save you a lot of headache and potentially worse than that if you do the wrong thing. So one last comment about AI tools. So I think the modern AI tools are amazing in many ways, but they're also dangerous in others. They can be really good for learning, right? So they can point to good resources. They can help summarize things very accurately. But some assessments, like your assignments, are meant to be your own work, so we'll prohibit their use in certain circumstances. So just like any other tool used, even if it's a website or even if it's Google, which is itself a form of AI, at least the search function is, mention that you're using it. Sometimes you might want to share links to chat logs where applicable. When you're using AI, when it's prohibited, this is an academic offense. So refer to the academic offense literature at the university. I'll just make a quick note also that a large part of why we do quizzes on paper and exams on paper without any tools is because really what a purpose of education is not just to get you familiar with how to use these tools, but developing your own cognitive state, right? What you know and what you have learned in terms of information that has been acquired in your head, but also how you go about learning new things. So we want you to develop your mental muscle in those ways, and the best way to do that is by actually thinking. So we'll be doing an awful lot of that this semester. Thank you so much. On to Module 1.